Okay, sir, you can start the session.
Okay, we'll continue. So, dear students, good evening to all of you, those who are joined, and welcome to Wings of Aero. We know that we are dealing with a new aircraft, that is our helicopter design. I hope all of you have completed the previous the previous aircraft model, the assembly part of commercial plane. So now we'll continue with this second part of this helicopter. Okay, that is our top fuselage. So before proceeding to this top fuselage, let me just copy this directory. Okay, part 1 main fuselage. Yesterday we have saved this file at 7:13 p.m. So just go to open VSP, run this one, go to file, open, and I'll just paste this directory. Control V, enter, select, and accept. So I'll just what I'll do, I'll just use this skinning option. Okay, just to smooth this geometry. That's it. Okay, because the shape it should be like this. Now currently our front view what we have, so it should look like this. Okay, top portion. This portion, just we will smooth this one quickly. It will take just a few minutes. Okay, welcome to first section. So here in this first section, okay, we'll just change this one also. We'll go with 90. Okay, so we will just on this checkbox. Okay, it will be. We'll jump to first cross section. Here, this first cross section, what we have, we will use this right side and bottom side parameters, and also top side. You can observe. Okay, so we'll go with 15. Okay, top side. Okay, and similarly right side, we'll use front view. Okay, we'll go with 45. Okay, it will be 40. Okay, let it be this much. Okay, so we'll just round off to 16. Okay, now next jump to first section, second section. Here also we'll do the same thing. Okay, we'll just go with 30, 35 plus. Okay, so we'll just go with 35. And this one, also will maintain 30 or 35. Okay, we'll go with 30. Next, right side. Okay. Okay, that will be. So we'll go with 6 or 7. We'll go with 6. Okay. And just on this checkbox. Okay, we'll go with 10. This is bottom side. Okay. So we'll go with 8. Okay. And on this one, okay, we'll go with 11, 10 or 11, 10. Okay. Okay. So now we'll jump to next cross section, third cross section. Okay, here let it be. No need to do anything. We'll just change this angle. Okay, that will be this one. So we'll go with -8, -6 or -7, minus. Okay, we'll go with -8. We'll go with -20. Okay. We'll go with -5. Okay, now it's correct. Top side angle, we'll just go with the okay, let it be this much. We'll round off to -30. Okay. Now we'll jump to fourth cross section. Here also we'll do the same thing. Go with the minus. Okay. We'll go with the 23. Okay. Okay. Now we will check the view. Okay. This one will maintain 90 degrees. Fourth one done. And okay. Okay, then we'll just save our first part once again. Just use save option. That's it. Okay. Okay, it has been saved. Now we'll just go to file and new option to deal with the second part, top fuselage. Once again, we have to just go to geometrical browser. We have to select fuselage and add. Okay, and the top fuselage shape, it should look like this portion. Okay, and that's what is shown here. Okay, so we'll just go with the parameters what we have. So part 2, top fuselage. So here we have the given data. Top fuselage length 8.65 meter. Okay, each and every cross section where it is located, that length is also given, and the type of cross section is also mentioned in the bracket. Okay, so we will use and we will complete this second part also. Okay, so for all length 8.65 meter. 8.65 meter. Now just observe the section 1, 2, 3, 4, 5, 6, okay, 7, 8. So like this, you can go with more than 6 or less than 10 sections to achieve this kind of shape. Okay, so 0th section, first section, second one, third one, fourth, okay, fifth, sixth. You can go with 6 also, you can go with 7 or 8. Okay, so here I mentioned totally 8 number of cross sections. Each and every cross sections where we have to locate, that length is also mentioned. from the nose point, and the type of cross section. We'll just go with this. Okay. So here default we have 4 number of cross sections. 1, 2, 3, 4. Okay. So we'll just insert 4 cross sections. 1, 2, 3, 4. Now once again I'll just check. 1, 2, 3, 4, 5, 6, 7, 8. So we have totally 8 number of cross sections. I will come to first cross section and I will just give the length 0.87. Okay, 7957 meter. 0.87957 enter. So this is our first cross section. Sorry. Okay, once again. Okay. 0. Enter. Okay, so we have located our first cross section. Now we will jump to second cross section. So this second cross section, it is located at a distance of 2.47, okay, 809 meter away. 2.4780 enter. Our cross section 3.12756 meter away. Third cross section 3.12756 enter. Fourth cross section 4.32361 meter. Four point 32361 enter. Next we'll jump to fifth cross section, and this fifth cross section, it is located at a distance of 7.80997 meter away from this nose point. Okay. So fourth is done. Fifth cross section, it is located at a distance of 7.80997 enter. And we'll jump to sixth cross section. This sixth cross section also located, okay, there itself. Seven point 80997 enter. 7 cross section 8.650 meter away. 8.650 meter enter. And last eighth one, of course it will take the overall length 8.65 meter. So we have located each and every cross section. Okay. Now what we have to do, we have to come to each and every cross section and we have to change the cross section type. We will just come to section and here we have zeroth cross section. Of course, default we have the pointed type of cross section. So let it be the pointed type of cross section itself. Okay. And now I will just come to first cross section. Here, what we have to do, we have to choose ellipse type of cross section and we have to give height and width, which is mentioned here. Okay. So here we have first cross section and the type of cross section, ellipse type of cross section. We have to give our height and width of this first cross section. So we have our height and width, height 0.97 meter and width 0.6939 meter. Okay, so we will use this one. So height, sorry, 0.97 meter, enter, and width 0.69395, enter. This is done. Next we will jump to second cross section. Here we have the second cross section type, that is ellipse type of cross section, which is having a height and width. Height we have to maintain same what we have done for previous cross section. Only the thing what we have to do, we have to do the change with this parameter, that is width. Just we have to increase the width. Why we have to increase the width? Because we can observe as we go from this point to this point, of course there is increase in the width, right? You can observe clearly this portion. Okay, yeah, so we'll just maintain same height, that is 0.97, enter. That's our height of the second cross section, ellipse height, and width 1.21522, enter. Yes. Now we will jump to third cross section. Here we have our third cross section. We have to use general features type of cross section. Okay. Okay. So we'll just choose the third cross section type, that is general features type of cross section. And here I just mentioned two parameters, that's it. That is the height and width. Height is 0.979618 and width 1.3, and rest other parameter what we have. Okay, this top structure, bottom structure, just we have to adjust till we achieve that required shape. Okay, yeah, so here we have the major parameter, that is height 0.79618, enter, and width 1.3, enter. Right now. Okay. Yeah, now what we have to do, we have to just mm, wait, let me enlarge this one. Okay, okay. So we have to just play with this top structure, bottom structure, upper structure, and lower structure. Okay. Okay, let it be top structure, top tangent angle, bottom tangent angle, let it be 90 degree itself. Okay, and here, okay, we'll just reduce this one little bit. Okay, okay, let it be. Okay, so we'll just jump to next cross section, fourth cross section. Here we have fourth cross section type, ellipse type of cross section. Okay, height is 0.71 meter and width 0.30 meter. Okay, so height is 0.71 meter, enter, and width 0.3, enter. Okay, yes. So fourth cross section is also done. Now next we'll jump to fifth cross section. Same, we have to maintain ellipse type of cross section itself, and height 0.3, width 0.120. Okay, height 0.3, enter, and width 0 0.12, enter. Okay, next we will jump to sixth cross section. Here we have sixth cross section. Again we have to choose same. Okay, height. Okay, yeah, type of cross section, it's ellipse type of cross section, and height 0.360, width 0.1730. Okay, 0.17230 meter. That is our width of sixth cross section. Okay, okay, so the sixth cross section type is ellipse type of cross section. You know our height, how much we have to maintain, that is 0.36, enter, and width 0.177, sorry, 17330, enter. That is our sixth cross section. Now we will jump to seventh cross section. Here we are. Okay, so yeah, okay, so here we have seven cross section type and the parameter, ellipse type cross section parameter, height 0.3600 and width 0.1 meter. Cross section type, it's ellipse type of cross section, height 0.360, enter, and width 0.10, enter. Okay, and now we have to jump to eighth cross section, and we have to close our geometry. So that's why the type of cross section we have to use pointed type of cross section, and that is what mentioned. Okay, so we have done with all the cross sections and the type of all this cross section. Okay, so here we have our top view, front view, and left view. So here what we have to do now, we have to come to window, we will use two vertical window, not vertical, we will go with horizontal. Okay. Okay, space is not that much convenient. Okay, then we'll go with two vertical window. Okay, now it will be easy to adjust. Okay, yeah, so here I'll click on this window. Okay, first vertical window, and I will change the view. Here we have top view, front view, and left view. I will keep this one. Okay, the view, left view. Okay, yeah, and here this one ISO view. So we have to change this straight fuselage, and we have to give this kind of shape what we have here. Okay, that is what now we have to do like this. Okay, so which axis we have to use? We have to use our Z axis. Okay, Z, because currently it is on X and Y Z plane. Okay, X and Z plane, X and Z. You can observe the plane what we have. Okay, okay, then we'll just come to X form. Okay, we'll just come to each and every cross section. Here we have 0th cross section. Okay, so no need to do any changes with this. We'll just jump to next cross section. That is our first cross section. Here we have to use Z axis. Okay, see, so we'll go with 0.0 point. Okay, we'll go with 0.1. Just observe once. Okay, 4. Okay, so let it be 0.14. And next what we will do, we will jump to second cross section. Here also we will do the same thing. We will maintain same. Okay, 0.14 itself. Okay, I will jump to third cross section. Okay, so here in this third cross section, no need to tilt much, so just go with 0.02. Okay, now next we'll jump to fourth cross section. Okay, yes, can observe this one. So which means we have to use negative z axis. Okay, suppose this is your 0, 0. Okay, then we are working with this cross section. Okay, so of course, uh, below the zero, the axis will be negative z, right? So we have to go with negative z axis. Fourth cross section what we have, we'll just take this one a little bit downward. Okay, so let me use for window, it will be easy to analyze. Okay, okay, yeah. So now we'll just so we'll go with minus 0.4. Next we'll jump to fifth cross section. Here also we have to do the same thing, negative z axis. Okay, let's see. So we'll round up to 0.20 or 24. Okay, yeah. Now we will jump to fifth cross section. This one also will translate along the negative z axis with same value what we have given for previous cross section, that is minus 0.24. Okay, now we will jump to seventh cross section. This also will keep same. Why same, sir? Why not you are changing? Why? Because you can observe it's completely linear state, no? That's why. 0 minus 0.24, enter. Next, eighth cross section, same. Okay, so we'll go with minus 0.25. Okay, we'll just take to 7. Now we'll just use one window. Okay, yeah, this is our top fuselage, this portion. I mean this. Okay, so you just save this one, go to file, use save as, and type part name. Part 2 top fuselage. Exit. Okay, so now we'll just go to insert and we'll choose main fuselage, accept. So you can observe easily. Now we can, we'll use top view. Okay, let's use 4 views. So you can assemble now itself, or later while assembling all the components, that time you can assemble. Okay, just you have to use this. Okay, here we have main fuselage and top fuselage. Okay, so we have to just translate this one along y. Okay, okay, so we'll translate along there. Like this you can fix. Okay, like this. So still we have to do all other parts, no? So that time it will fix perfectly. Okay, I'm just showing roughly. Okay, like this. So you can call this one as a complete fuselage. You can save this one. Now I don't want to save because here separately we have two parts. Okay, okay. So while doing assembly of all the component, that time we'll call this component separately, and once again we'll just assemble. Okay. Now currently we have to just go to file and new option. Why new option? Because now we have to deal with third part, that is tail fin. Tail fin in the sense this portion. This portion. Okay. Tail fin 1, tail fin 2. So here I mention the parameters of tail fin 1. Also I mention top view, front view and left side view. After this we'll go for tail fin 2. So it will take just a few minutes. Tail fin 1, of course, this is our wing kind of geometry, so that's why we have to go to geometrical browser, we have to select wing and add. Okay, we don't want the symmetry because we are designing the separate components. Okay, tail fin 1 and tail fin 2. So we'll first go with tail fin 1, this one. Okay, like this what we have, this portion. Okay, so let's off the symmetry and just input this parameter. Overall span 1.55 meter. Just 2 minutes. Yeah, so from here to here span is 1.55 meter. Okay, I just directly will use this one. Now go to platform and give the span value 1.55, enter. Okay, and chord 0.5110 meter, chord length 0.511, enter. 511. Okay, 0 in the sense 511. Okay, yeah, and directly we have to come to root chord and tip chord, which means in this section, okay, here we have root chord and tip chord. So here no need to split the section because geometry is a simple geometry. Tail fin geometry, what we have, it's simple geometry. Okay, one wing section is also enough. Yeah, so here we have the root chord 0.71 meter, 0.71 enter, and tip chord 0.312 meter, tip chord 0.312 enter. Okay, and sweep angle 33.36 degree. You can observe clearly the sweep angle we have. Okay, if I draw straight line, then this is our sweep angle, that is 33.36 degree. Sweep angle 33.36 enter. Yeah, yes, now we have to come to aerofoil. Okay, default we have the same aerofoil Naka 0010. Okay, if you want to change, you can change. If you want to maintain the same default aerofoil, let it be. Okay, yeah, so here we have done with our tail fin 1. We'll just shade this one, and here we have top view, front view, and left view, and here we have all the 4 views. Okay, yeah, so we'll just go to file. Let me share this. Okay, later no need to change the name. Here I'll just call this one as tail fin 1. Enter. Okay, so now I'll go to file, use save as option, and give the part name part 3 tail fin 1. Enter or accept. Yeah, now we'll go for next part, tail fin 2. Tail fin 2 in the sense this one, lower portion, this one. Okay, now we are dealing with this one. Okay, so tail fin 2, given data, what we have, the span 0.79 meter. So go to file, new, again select the wing, and we don't want the symmetry, so that's why come to general, sorry, in this X form, and of the symmetry. Okay, and use all this given data, span 0.79 meter, 0.79 enter. Okay, okay, and chord length 0.53 meter, chord length 0.53 We have to come to section and we have to use root chord, tip chord and sweep angle. Root chord 0.72 meter, enter, and tip chord 0.34 meter. Enter. Sweep angle 28 degree. Okay. So here we have sweep angle 30 degree defaultly. You have to change this to 28 and enter. Okay. Now share this one. Okay, yes. Yeah. So we have done with the tail fin. Just we have to rotate like this and we have to fix. Okay, while assembling this portion, okay, I mean like this tail fin too, you have to assemble in this manner. Okay, yeah, so we have done with this one and this one. Next we have tail plane. Okay, so it will take just few minutes, then we'll stop. We will go for rest of the components tomorrow. Okay, so here we have to go for tail fin. Let me save this one. Tail plane. Okay, yeah, so we'll just give the name tail fin 2, enter. Shade this one, use one window, go to 5, save as, give part name part 4 tail fin 2, accept. Okay, so here, yeah, 1 2 3 4, all 4 parts has been saved successfully. Now we'll go to file, new, and here we have 5th part, tail plane. So this portion, this one, okay, that is our tail plane and it is like this. So we have overall span that is 3 meter. So go to geometrical browser, select wing, add, and yeah, so here we have to on our this symmetric checkbox along xz. Okay, why we have to on? Yes, according to this geometry, easily we can say we need a symmetry here, all right? So that's why no need to off the xz symmetry plane. Let it be. Okay, so we'll come to plan form. Okay, so total plan form. Okay, the span what we have for this case, that is 3 meter. So we'll use that given data, 3 meter, enter. That is our overall span. Chord length 0.38281. 0.38281 meter, enter. 0.38281. Okay, yeah, so these two parameter done. Now next we'll go to this parameter root chord. Yes, so we have to come to section. Here we have root chord. So root chord length 0.36458 meter. That is our root chord. Okay. 36458. 0.36458, enter, and tip code 0.40104. 0.40104 meter, enter. Okay, yeah. And sweep angle, yes, we don't want sweep angle because this part what we have tail plane. Okay, it's completely like a rectangular shape. Okay, where we don't have any sweep angle. Okay, so that's why the sweep angle is 0. I mean, like here we have to change this 30° to 0° and enter. Say, as soon as we entered the sweep angle 0°, complete wing geometry has been changed. Okay, and this is our required tail plane what we are looking to design, and that is what we got according to our input parameter. So that's why designing is not that much hard, but understanding the parameter, okay, that is very very important, and you have to feel those values. Simply if you are typing and getting the model, it's no use. You have to feel that parameters, whether you are giving 0° or 10° or 20° or 30°, that is your sweep angle, root chord and all. So you have to feel your value, and you should analyze how the model it may look if I give that input parameter. So just share this one. We have all 4 views. Okay, so this is our tail plane. Aerofoil, okay, that one we just maintain same default. Let it be 22. Okay, thickness to chord ratio, just go with 22, enter. Okay, yeah. Okay. Yes. Yeah. So we'll just share this one. Select. Okay. We'll just give name also. That is tail plane. Enter. Share this one. Go to file and save as. This is our part 5. Except. So I'll just stop this session. Rest other parts we will continue tomorrow. It will take just half an hour. Then we'll go for assembly and we will complete the helicopter model. Okay. So ensure that you'll be completing all these 5 parts. Okay. Before starting the tomorrow session, because next other part once you complete, then easily you can go assembly with me. Okay, I'll stop the session. If you have any questions, you please use chat window or use mic. Yes, any questions? Okay. Students, I hope I'm audible. Any questions from your side? Yes or no? Just type on a chat window. No, sir. Okay. Kritika is telling no. Okay. So we'll just consider that no any questions or no any doubts from your side. Okay. 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 Thank you to all of you. Thank you for response. And please ensure that you'll be completing all these parts. Okay. What we have done, all 5 parts. And rest other parts will be completing tomorrow. It will take just few minutes. Okay, after that we'll go for assembly. So please work on this. That's why we are not giving any assignment, so that you will be in a touch and you'll be in a flow with me. Okay, yeah. So sir, we'll stop the session. Students, they are telling no any doubt.
Okay, sir. Thank you.
Okay, so thank you students. Thank you for joining. We'll continue tomorrow.